Good morning, everyone. Welcome back. I'm Steve.
And I'm Scott.
And together we are Backyard Musings. I'm back in Apple Valley. We survived Legoland.
I'm in Apple Valley as well, but it is over the 100 mark. So I think that's why we're probably doing it inside.
Blazing hot. Oh,
yeah,
man.
Really hot.
Blazing hot.
Really hot.
Yeah.
And we're definitely talking science and technology today. This is a wild story. I hope you don't offend any small stars out there by calling them dwarfs.
What you see on your screen now, that's the Hubble telescope. We talk a lot about the Hubble telescope, but I never knew what it looked like. Here it is, right here.
Yeah, and it's been up there a while. It's been up there a while. So, and it's got some really cool photos and pictures, and yeah, good data.
You can see the solar panels there for energy to power the telescope, move it around, thrusters, that kind of stuff. Yeah, it's the Hubble telescope.
Yeah, just a floating telescope. It's amazing.
A seemingly ordinary white dwarf star located just 130 light years away has revealed an extraordinary secret. It is the aftermath of a rare and violent stellar collision. Using the Hubble Space Telescope, which you see, it's ultravision, astronomers detected, I said ultravision, I mean ultraviolet vision. Yeah, that's a good contraction there. Astronomers detected faint carbon traces rising from the star's core, a telltale sign of two stars merging into one. Would you like to know more?
Astronomers at the University of Warwick have found strong evidence that a nearby white dwarf is actually the aftermath of two stars merging, a rare type of stellar remnant identified through ultraviolet observations from the Hubble telescope, or Hubble Space Telescope, sorry. These observations revealed carbon in the star's scorching atmosphere, offering a clue to its unusual origin.
Yeah, this is really fascinating. White dwarfs are the compact remnants left when stars burn through their fuel and collapse. They are roughly the size of Earth and is really dense, but have half the sun's mass, with carbon-oxygen cores wrapped in helium and hydrogen layers. While such stars are common, white dwarfs are masses greater than the sun, are unusual and not fully understood.
In new research published in Nature Astronomy on August 6, 2025, the Warwick team examined WD0525 plus 526. I'm not sure what that number means.
525 and 526. So one star is 525, the other star is 526.
Got it. High mass white dwarf located 130 light years from Earth, which is what Steve mentioned earlier. The star's mass is about 20% higher than the sun's, placing it in the ultramassive category. Okay. The puzzle for astronomers has been how massive a white dwarf could have formed. Okay.
Yeah, how can it form? Although it's possible for a white dwarf of this size to be created from the collapse of a single massive star, Hubble's ultraviolet data told a different story. The star shows small amounts of carbon moving from its core into its hydrogen-rich atmosphere, a signal that it likely formed when two stars merged rather than from the death of one large star. Typically, thick layers of hydrogen and helium surround a white dwarf's core, hiding heavier elements such as carbon from view. Oh, that's yours.
That's all right. Go ahead.
In the violent process of two stars combining, these outer layers can be almost completely stripped away, leaving only a thin shell. This thin envelope no longer blocks carbon from reaching the surface, which is exactly what scientists observed in WD 525 and 526.
You want to read the next one too? Go ahead. Go ahead and read the next one too.
Antoine Bedard, Warwick Prize Fellow in the Astronomy and Astrophysics group at Warwick and co-first author, said, quote, "We measured the hydrogen and helium layers to be 10 billion times thinner than in typical white dwarfs. We think these layers were stripped away in the merger, and this is what now allows carbon to appear on the surface."
Okay, 10 billion times thinner.
Yeah.
I mean, how do they come up with that? That sounds like, well, how much do you love me? I love you bazillion. I mean,
So
I don't
that's
know.
10 to the minus 12, right?
That's pretty thin, right? 10
Yeah,
billion
10 to
times
the
thinner.
minus 12. Yeah.
Yeah.
That's really thin.
Yeah. Adding to the mystery is how carbon reaches the surface at all in this much hotter star. The other merger remnants are later in their evolution and cool enough for convection to bring carbon to the surface. But WD0525 and 526 is far too hot for that process. Instead, the team identified a subtler more form mixing called semi-convection. Okay. Seen here for the first time in a white dwarf. It's the slide, right? This process allows small amounts of carbon to slowly rise into the star's hydrogen-rich atmosphere. Okay.
As WD525 and 526 continues to evolve and cool, it is expected that more carbon will emerge at its surface over time. For now, its ultraviolet glow offers a rare glimpse into the earliest stage of a stellar merger's aftermath and a new benchmark for how binary stars end their lives. Now, what if this is just a black hole has ejected two stars? Well, that would be cool.
Yeah, I don't know. That looks a lot like a poster that's hanging up at my optometrist's office that I was just at a couple of days ago. So
that is an artist rendition. That's not a live photo.
Probably the same artist used to do the poster at the optometrist's office. Looks very similar.
Yeah, but this is cool, fascinating. I mean, fascinating science.
Yeah, and anytime something it's bigger than the sun, right? We talked about that. 20% higher. Yeah, the mass. That's big. I mean, we don't have anything in our solar system that's bigger than our sun, except for the sun, right? So
right. I mean,
pretty fascinating.
Yeah, Jupiter's not even close to the sun. Yeah.
Right. Yeah, fascinating stuff. So be nice if we could get out there a little closer, get some good shots of it.
We need faster than light travel. That's what we need. Faster than light travel.
Yep. Somebody out there needs to work on that.
Yep.
I think they already are. Take
All
care.
right, folks. Thanks for joining us. We'll see you.
Thank you. See you later.